Hello student. Today I am going to discuss about electrical potential. Electrical potential energy already discussed, and relation between electrical potential energy and work done we have derived in our previous video lecture. Or also we have gave some notes related to that. Now we have to derive the electrical potential. How it is related we have to find. Now we already discussed that electrostatic force, gravitational force are all conservative force, and we know that related to conservative force, that we know this formula that del. Before that, I am just giving definition of electrical potential. Electrical potential is defined as the potential energy per unit electrical charge, or electrical potential. It is defined as potential energy per unit test charge. Potential is generally denoted by V. So simply we can write this formula V equal to U by Q naught. Okay, where U is the potential energy and Q naught is the test charge. Now, okay. Now, as the electrostatic force is a conservative force, and we know that this formula already discussed, that del U equal to minus of W A to B by A to B. Okay, as the electrostatic force is a conservative force, where del U means change of potential energy, and here WAB means what? We are displacing a Q naught test charge from A point to B point. So work done for displacing a test charge from A to B point, it is denoted by WAB. Okay. Now from this equation we can write UB minus UA equal to minus of WA to B. Okay. UB means potential energy at B point, and UA means potential energy at A point. So change of potential energy UB minus UA, which is del U. Now dividing both sides by of this equation by Q naught, then what we have? UB by Q naught minus UA by Q naught equal to minus of WA to B Q naught. Okay. Now using this relation V equal to U by Q naught, so here UB by Q naught is VB. It means potential at electrical potential at B point, minus of VA electrical potential at A point equal to minus of WA to B Q naught. Okay. So now it can be written as VA minus VB, taking minus this side. So WA to B Q naught. So this is the expression of potential, change of potential and related to work done between 2 points. Okay. Now this work done is work done by the electrostatic force. Okay. Now what will be the relation of potential, or before that we can write VA VB, we can write this as VAB. It means potential difference between A and B point. This can be written in this way also. VAB equal to WAB by Q naught. Here specifically you can write WAP equal to electrostatic force. Work done due to electrostatic force. Okay. Now work done between this, what will be the relation between potential difference and work done by the external agency or external force? We can write VA minus VB equal to minus of WA to B Q naught. Here WAB. Okay, so this is external force, work done due to external force, or this expression can be written VA minus VB equal to WB to A by Q naught. External force. So this is the relation between potential difference between A and B point and work done due to external force. Okay, this will be Q naught. So these are the two formulas related. This is relation between potential difference and work done due to electrostatic force, and this is the relation between potential difference between 2 point A and B and work done due to external force. Okay, so these are the two relations. Now next we have to derive the absolute potential, electrical potential. For that, absolute potential. Okay, absolute potential. Now here we have considering that at B point, B is infinity. B point situated at infinity. So we already know that potential at B point, if it is denoted by VB, equal to 0 there. So by using previous expression, VA minus VB equal to WAB electrostatic force by Q naught. Okay. Now at B point we have considered it is situated at infinity or infinite distance, and we know that potential at infinite distance will be 0. It means, okay, so VB equal to 0, putting that value, so VA minus VB here 0, potential at infinite distance, W A to infinity, B point situated at infinite distance, so electrostatic force, work done due to electrostatic force, Q naught, or VA equal to WA to infinity electrostatic force by Q naught. This is another formula to find absolute potential at any point. We can define how we define electric potential at point A is defined as the work done to displace a Q naught charge, mean Q naught test charge, from point A to infinite distance. How much work done we have to do? That work done is equal to potential energy at A point. Okay, this is VA equal to electrostatic force, the relation between absolute potential at any point and work done. Okay, now same way we can find the absolute potential at A point due to external work done by the external agency. So by putting this in this expression, so VA equal to, or I am writing directly, just proceed in this way. VA equal to W infinity to A external force by Q naught. This is another expression related to external force. How we define it? It is the means potential at A point is equal to the work done to bring a test charge from infinite distance to at A point by the external force. This is the relation between absolute potential at A point and work done due to external force. So these are the another two relations, and these both relations are related to absolute potential. One in case of electrostatic force, another in case of external force. So total, okay. So simply we have to remember these three formulas to solve the numerical problem. Okay. So first, VA minus VB equal to W A to B external electrostatic force, work done due to electrostatic force by Q naught. This is one formula. Another, VA minus VB equal to W A to B, and writing togetherly ELE, electrostatic force by Q naught equal to minus of W A to B external, work done due to external force by Q naught. This is very important relation. Okay, and another related to absolute potential, we can write VA equal to W infinity to A Q naught, or W infinity to A Q naught V, and this is external force. Okay, so these are the few relations related to work done and potential difference. Okay, so just go through this, and this relation is very useful to solve the numerical problem. We have to use these relations. Now next we have to find the electrical potential at a point due to a point charge. So now electric potential due to a point charge. Suppose we have a point charge Q placed at this point. We have to find electrical potential at this point at a distance r. Let electrical potential due to this point charge at this point, this is O point, this is A point, at a distance r, let it is denoted by V. Okay. Now from the relation we know V equal to U by Q naught. V equal to U by Q naught. U is the potential energy. The potential energy at A point due to this point charge is 1 by 4 pi epsilon naught Q naught by R by Q naught. Now Q naught cancel. So put V equal to 1 by 4 pi epsilon naught Q by R. So this is the expression of potential at a distance R due to a source charge Q. Okay. So this is another formula. So we have to use all this formula to solve numerical problem, and also when we discuss the capacitor, we have to use this formula also. So just go through this. Now next, like potential energy is a scalar quantity. Means what I said, we have, suppose we have lots of point charge present. We have to derive the potential energy for due to all these point charge in an isolated system. So what we have to do? We have to just sum individual potential energy algebraic way. Similarly, as the scalar means potential is also a scalar quantity, so potential energy due to a system of charges V equal to summation system of charges, so 1 by 4 pi epsilon naught Q I by R I. This is the formula to find the potential energy due to a system of charges. Total potential energy, if it is denoted by V, so V equal to summation of 1 by 4 pi epsilon naught Qi by Ri. Okay. If there are two charges present, so what is the potential energy? The potential in this system, that will be 1 by 4 pi epsilon naught Qi Ri plus 1 by 4 pi epsilon naught Q2 R2 in this way. So we have to do the algebraic sum to find the potential at a when system of charges are present. Okay. So just go through this this section and try to solve. I will give some numerical problem and try to solve that numerical problem. Okay. Thank you.